Hello students, that's class. We learned about the formation of electric arcs and understood the hazards of arcs. So today, we will learn how to reduce the hazards caused by arcs, which is the content of this lesson. The deionization process of electric arcs. In this lesson, the content we need to master is the process of deionization and the factors affecting deionization. Through learning, we must develop a spirit of daring to explore and actively innovate, and enhance awareness of electrical safety and social responsibility. The key points of this lesson are the process of arc deionization and the factors affecting deionization. The difficult point is the process of arc deionization. The deionization process of electric arcs mainly includes two forms, recombination and diffusion. So what is recombination? What is diffusion? Recombination is the phenomenon where positive and negative charged particles combine to become neutral particles, because electrons move very quickly. So the probability of electrons directly recombining with positive ions is very small under normal circumstances. First, electrons collide with neutral particles and become negative ions. Then, they are attracted to positive ions with similar mass and velocity, approach, exchange charges, and become neutral particles. Diffusion is the phenomenon where charged particles in the arc column escape from it and enter the surrounding medium. Diffusion occurs in the following three forms. First, thermal diffusion, due to the significant temperature difference between the electric arc and the surrounding medium, causing the high-temperature charged particles in the arc to diffuse into the medium with lower temperature. This reduces the number of charged particles in the arc. Second, concentration diffusion. This is because a concentration difference exists between the arc and the surrounding medium. Charged particles diffuse from the area of high concentration to the area of low concentration. This reduces the number of charged particles in the arc. Third, blowing-assisted diffusion. In circuit breakers, high-speed gas blast is used to blow the arc. It carries away a large number of charged particles from the arc to enhance the diffusion effect. So, what factors affect the deionization of the arc? First, arc's temperature. Its principle is that it is sustained by thermal ionization. Lowering the arc temperature can weaken thermal ionization, reduce the generation of charged particles, and simultaneously reduce the velocity of charged particles. This strengthens the recombination effect. The methods are by rapidly elongating the arc, blowing the arc with gas or oil, or bringing the arc into contact with the surface of a solid dielectric. All these methods can lower the temperature of the arc. Because the temperature of the arc is relatively high, it can easily burn out the insulating materials, causing electrical leakage. Therefore, awareness of safe electricity use must be raised. Second, the characteristics of the medium. Its principle is that during arc burning, the characteristics of the medium in which it exists to a large extent determine the intensity of deionization in the arc. These characteristics include thermal conductivity, heat capacity, thermal ionization temperature, and dielectric strength. Third, the pressure of the gaseous medium. Its principle is that the pressure of the gaseous medium greatly affects the deionization of the arc. The greater the gas pressure, the greater the concentration of particles in the arc, and the smaller the distance between particles, the recombination effect becomes stronger and the arc is more easily extinguished. The method is in a high vacuum due to the reduced probability of collisions. Collision ionization is suppressed. However, the diffusion effect is enhanced. Therefore, vacuum is an excellent arc extinguishing medium besides vacuum. Are there other arc extinguishing media? Students can explore this further after class. Cultivate a spirit of daring to explore and actively innovate. Fourth, contact material. It is when the contacts are made of metals that have a high melting point, strong thermal conductivity, and large heat capacity, and are high temperature resistant. This reduces thermionic emission and metal vapor in the arc. This is beneficial for arc extinction. This lesson mainly introduced the process of deionization and the factors affecting deionization. Now, students can consider the following questions. What are the main methods of arc deionization? What factors affect the deionization of the arc? That concludes the content of this lesson. Thank you for listening, students.